Okay, so next set of topics to use or to consider is something like this. How do we now access individual data pieces inside of our structure? We just said that in the rules of encapsulation suggest that in object-oriented programming, the data should be protected inside of the object, and only object functions such as this constructor should be able to manipulate those data fields directly. So that's why we have this private label, which essentially tells, look, this portion of the object, month, day, and year, this specific portion of the object is actually something that cannot be easily accessed externally. To deal with this, what normally happens that we write some accessors functions. In Java, you would call them accessor methods. And it's simply this, say void set month, right? Set month, and we can pass an integer month, the new value, right? And likewise, we can get integer get month. So it's like a getter and setter, which simply returns whatever the structure already stores. Okay, so accessor functions, and similar would be for day and year, but right now, to save some time, I will just demonstrate it with set month and get month. Right? So these functions, as you notice, I declare them inside the structure. Right? These are not freestanding functions. They're member functions of the structure and designed to work with this structure. So let's see. I can copy and paste my prototypes, which just have the semicolons inside the structure, and place them in my implementation file right here in my implementation file. But now I need to tell the compiler that these are not freestanding functions. They're actually coming from the definition of my date structure. So I have to prefix them by saying date. Basically, get month and set month belong to the class, structure named date, right? And they're really dealing with the scope of that specific structure. Now, of course, implementation simply uses the curly braces to provide now real function definitions to our structure. And when we say set month, we again do something like this: month equals month, right? So this time function set month, unlike constructor, populates only one component, and it's the month value that we pass. And of course, get month simply returns month that is already stored in our structure in the memory. So then back to implementation of main, which is like the client of our date structure. Right here, instead of going directly and saying month, I can say just get month. Right, get month. Let me resize this so you can see everything side by side, all of my code. Right, so this time get month is a member function that belongs to the date, and the member functions, the member function calls are somewhat different compared to regular function calls. The main difference is that the first argument to a member function call, such as get month, appears to be the name of our object, right? So you cannot call get month without an object. You really have to provide which object, because on the next, so this is like birthday month, right? Today's month is today, right? The today thing. Today get month. So these are the two different objects, right? Because if this is today, then it's going to return this month. If this is today or birthday, it's going to return this different month. Okay, so as you can see, in order to invoke any of these member functions, set month, get month, I have to provide an object on which this member function is invoked. This is somewhat similar to so the syntax really doesn't work, but I would like to give you a demonstration of it, is that with every member function call, it's almost like saying, like this becomes an invisible parameter to the function when the function is invoked. Something like that, right? So it's almost like saying, look, we have a function inside date, right, which is get month, and it implicitly gets a pointer or address to or address of the object on which it was invoked. Obviously, this syntax is just a demonstration of the concept, but just remember that when you call member functions, like normal member functions of your structures, then you providing the object name, and it becomes an implicit invisible argument inside the function. So that's why the function has no hesitation realizing that get month, right? So we're trying to call get month. This is the implementation of the function. It just says, oh, return mm. So what's mm? Mm is an integer inside of our structure, right? So we have the month component. So it basically just says, okay, I'll give you a copy of that integer, right? So it makes a copy of that integer and returns it all the way back to the caller. In our case, the caller is this stdc out statement, which trying to piece together the string of characters which it is about to display. So it prints birthday month and then goes to birthday and calls this function get month, which returns this, and it basically returns the value stored inside birthday, the month thing, and it gets displayed eventually on the screen, right? So we really make a function call, but this function does get a hidden pointer to, or hidden address of the actual instance of the function. Because if the next time I call today get month, as opposed to birthday get month, of course, that hidden pointer will be first time it's pointing to, so when they say get month, right, which executes, right? So the first time it gets access to one object, the second time it gets access to another object. So the first time I return this value, the second time I return this value from this function get month. Okay, so that's not obvious from the syntax, but that's the actual interaction that happens inside, and this is how compiler interprets and compiles our programs.